Hi, I'm Mikayla. I'm a PM on the Visual Studio for Mac and Xamarin Platform teams at Microsoft. And I am here to tell you about the Mono Runtime, which is a very important piece of technology that powers those two things. And I also tweet occasionally. I mostly reply to tweets rather than tweeting, so if you have questions, tweet them at me. So you might be wondering, well, first of all, who here has heard of Mono? OK, that's a good count, but I see a few people haven't. OK, so it's an open source implementation of the .NET Runtime that was created almost 20 years ago to run Linux desktop apps. And since then, it's spread to pretty much every platform that there is. And when Microsoft acquired Xamarin about a year ago, it became part of the .NET Foundation, so it's now under the .NET umbrella. It's one of the .NET runtimes. So it has a desktop framework which underlies VS for Mac, which is essentially .NET 4.7, modulo a few big pieces of Windows-specific technology like Windows Forms and WPF. There's also the mobile framework, which is a framework profile that's essentially Net Standard 2, which is tuned and optimized to be able to be linked into small apps. We have a linker that takes that framework and just trims out all the bits you're not using, so your app just ships the bits that your app is using. And we did a lot of work on that to make sure that it can be trimmed down like that, and that it works well with our full AOT, our ahead-of-time compiler, which we use on platforms where you can't JIT compile. It's also very easy to embed. There's a simple C embedding API. I'll talk a bit more about this later. And it's very portable. And I'll be talking about that a bit more later as well. So we have a pretty frequent release cycle. We released 5.0 about a month ago. We released 4.8 towards the beginning of this year. 5.2 is already in preview, will be released shortly. 5.4 has been branched already. Master is already at 5.5. A lot of the things I'll be talking about today are from the 5.0 release. That was a big release. We put lots of cool things in it. A few of them were in 4.8, and a few of them are in 5.2, so you'll need the preview build to check them out. Now, there's a lot to talk about, so this will be a bit of a whirlwind tour. The first thing I'm going to talk about is our toolchain. In 5.0, we massively overhauled our toolchain. We replaced our XBuild, MSBuild implementation with MSBuild itself, MSBuild 15. In Mono 5.2, that's now 15.3. We replaced our C# compiler, MCS, with the Roslyn C# compiler. So we now have Roslyn 2, which gives us all the wonderful goodness of C# 7, and also gives us support for build time analyzers and things like that. We also switched out our frameworks to now have reference assemblies. So previously, when you built against one of the 4x profiles, like 4.0 or 4.5, it would really resolve to whatever the latest framework was. Now we ship reference assemblies for 2.0, 3.5, 4.0, 4.5, and so on. And so when you reference a framework, you're compiling against the actual exact version of the assemblies in that framework. Another really big thing we did, which spans the entire toolchain, is that we added support for portable PDB symbols. So that spans from the compiler, which has to emit them, then the build system, they have to go all the way through the build system, our linker has to support them, and then the runtime has to be able to load them to give you line numbers in your stack traces, and so on. And our debugger had to support them as well. So that was a big piece of work to get all of those things lined up. But now it means that the same symbol files that you use for .NET Core, you can use with the Mono runtime. So you no longer have to worry about there being two different symbol formats and having to convert between them. So next I'm going to talk a little bit about the runtime. And specifically, the garbage collector. So this here is a chart of pause times, which is the runtime frequently has to pause to do garbage collections. Well, not so frequently. It depends how much garbage your app creates. And the length of those pause times depends on a lot of things. It depends on whether it's collecting. It depends on the heap size. It depends on the amount of garbage you've created, on the nature of the things in the heap, and so on. This is a graph of the number of pauses that fall in a particular time range. And this shows the impact of our new concurrent GC. So in 5.0, we shipped a mode for the garbage collector turned on by default so that the garbage collector can now collect garbage from the major heap in the background without stopping your app. It does have to pause your app briefly to synchronize things, but that actually completely eliminated the really long pauses, which is great if you have a game or an app where users are typing into it and you don't want it to hang for half a second or so. If you have a really big heap that needs that takes a lot of work to collect. In 5.2, we also have an experimental parallel concurrent GC, so we use multiple threads for that background collection, which is even better. We've also been doing a lot of work on what we call our cooperative GC. So one of the interesting things about Mono is that we've ported it to a lot of platforms which have interesting restrictions, like platforms where you can't JIT compile, or platforms where you can't stop threads. So not being able to stop threads is a bit of a problem, because when the garbage collector needs to stop the world so it knows that things aren't changing while it does things, if the OS doesn't let it say, hey, stop all the threads, that's a problem. So we implemented a cooperative mode, so we compiled checkpoints into the code, we modified our I/O layer, our threading layer, and so on, so that the runtime, the garbage collector can request the runtime to stop, and those threads will, in a short time, stop. And that enables us to run on platforms like watchOS and PlayStation 4 and so on that have these restrictions. So moving quickly along in our whirlwind tour, we love CoreFX. We've been working with the CoreFX team to bring code from the CoreFX BCL into Mono to make sure that we are up to date with .NET Standard 2. But that goes both ways. The CoreFX team has also taken some code from Mono as well and integrated that into their repo. And this is an area of convergence for us, and it's something that we've been working on, we will continue to do a lot of work on. It's what's enabled us to move forward so quickly. And there are some other pieces of technology from Mono that are used by .NET Core as well now, like our linker. So, the runtime. The runtime is a big thing. We've done a lot of work from offline symbolication. So if you run your app without symbols, we now generate stack traces with offset information, and then we have a tool that can take the symbols and convert that back into file line number information after the fact. We've been working a lot with static analysis on the runtime itself to try and find problems preemptively that can be found with that, and a lot of other ongoing work on reliability there. We now have accelerated support for SSE, SIMD, via LVM. So if you're using the vector classes, those are now hardware accelerated. We've been doing a lot of work on reducing the size of our generics. When you compile an app that has a lot of generics, you get a sort of size explosion as it reifies all the different versions. And so by sharing reified versions between different types, we can reduce that size explosion. We also replaced our TLS stack. So we still have an old managed C# TLS stack for web security and so on. But writing a secure stack is a lot of work. It's difficult to get right. So we now have an option which is enabled by default, which is that on Mac platforms, we use the underlying Apple TLS stack, and on other platforms like Linux and Android, we use Google's boring TLS stack. So I mentioned earlier that we run on a lot of platforms. This is most of them. I'm pretty sure I missed a few off. Not all of them are as actively developed as others, but these are all still, these work. There are a few I'd like to call out. In particular, Xbox One and PlayStation 4, we've been doing a lot of work on which enables developers on those platforms writing games to embed the runtime into their game engine and get all the wonderful goodness of C# and F# there. We've also ported Mono to UWP, WinRT, which the reason we've done this is because, as I mentioned earlier, we have an embedding API, and since we have ports to all these platforms, if you embed the runtime, you can just use that same runtime across all the platforms. You don't have to abstract out to use different runtimes on different platforms and so on. One of the more challenging ones here has been the LVM bitcode. That does have a lot of restrictions that we had to work around with the kind of, we can't necessarily generate some of the things that we used to generate and had to find new code emission patterns on that. That also has some of the threading restrictions and so on. So a lot of these platforms do bring challenges, particularly those thread stopping and non-jitting limitations. So one of the things in the runtime that we're very proud of is our ahead of time compilation support. There are challenges doing AOT. Like if you look at NGen, for example, even though it precompiles most of what's needed, there are certain things that you can't statically determine what variants of reified generics you'll need ahead of time. So even when you're using NGen or our hybrid AOT, it still has to JIT compile some things. But running on platforms where you can't JIT compile at all is a challenge. So we have various tricks that we've come up with over the last 5 or 6 years of having a port to iPhone, which has these restrictions, that pretty much fix this problem. So embedding. This is how you embed the mono runtime and load an assembly, find a method, and invoke it. Now, there are simpler ways. If you just want to run main, you could actually reduce this down to a single line. There's a helper. But embedding lets you do lots of really cool things, like the Unity game engine, for example, embeds Mono, and that's how all of their users get to use C# to script their games. And we've actually been working with Unity recently to upgrade their version of Mono to the latest version, which is very exciting. All of those developers are now going to get access to C# 7, which is a big upgrade from C# 3. We also have a plugin to add C# support to Unreal Engine. We haven't been able to release it just yet, but I hope to release that very soon. If you are interested in that, come talk to me afterwards. There are some other cases like the Rhino 3D 3D editor embeds Mono as a scripting language. And actually, something else that we announced really recently at Build, which James Montemagno talked about yesterday, our Embeddinator 4000, essentially uses the embedding interfaces to embed Mono into an iOS or Android app, and then load your C# code and expose that to Android and Objective-C. So embedding is super cool. You can do a lot of really interesting things with it. So next, IoT. This thing here is actually sitting right here. This is a little Raspberry Pi. And I am going to switch to a demo. So just let me boot this up. And make sure I'm on the right Wi-Fi. So this is, let's see. Wait. How do I, OK. Is that, nope. OK. There we go. Demo. So this is Visual Studio for Mac, which is powered by the open source Monodevelop IDE, which you can use on Linux as well. And this is the preview, which includes our IoT support. So if I open up this IoT project that I created the other day, check this thing actually connected to Wi-Fi. It looks like it's trying. Debugging IoT devices is a little tricky without a monitor. But let's see. So this is an IoT project. You can see here it is a new SDK-style project using the Xamarin IoT SDK and a target framework of Net 461 and referencing a NuGet, which is Raspberry Pi I/O there. And this is my program here, which just gets the GPIO pins and writes some values to them. So if I run this, it builds, and then it opens up the IoT device manager. Now, this thing enumerates Raspberry Pis and other devices that advertise themselves as having SSH available, and you can connect to these devices. Hopefully it'll, yes, there we go, it connected. And now we can run. And this has connected to the device by SSH. It's deploying code to it. And as soon as it finishes deploying code, here we go. and it's running. And you probably can't see that from the back, but here it is blinking LEDs.
Sorry about that.
OK, so back to the slides. Oh, and also, if you want one of these awesome using mono stickers, there's a load on the table at the back. If they run out, come talk to me. If you're using VS for Mac, if you're using Xamarin, you're using Mono, go ahead and show it. Show the world. Oh, and let me actually switch displays. There we go. OK, there we go. So the awesome using Mono sticker. So the IoT support actually uses another great embedding bundling feature of our runtime, which is MKBundle. This takes an executable and bundles it and its dependencies with the runtime into a single binary. So if you want to distribute that to Linux or Mac or Windows and so on, it bundles that. It's a lot simpler. It looks like a single executable. So we recently added support to MKBundle to do essentially a form of cross-compilation. And as you can see here, this is running MKBundle. It lists all of the target runtimes it can deploy to. There's a lot of them. And then you just run MKBundle -- cross or something like that. And it downloads the runtime and bundles that with your app. So for the IoT support, you can, when you're building a release build, you can select which platforms you want to target, and it'll build single executables that are much easier to deploy to those devices. And I promised I'd tell you a little bit about what's coming soon-ish. So here are some things we're working on. I can't promise when they'll arrive, but we have an interpreter. We just recently resurrected the old mono interpreter because this will enable us to do things like we can do dynamic code gen on devices that don't support JIT, like iPhone and so on. We've also been working on runtime support for new language features that are currently experimental, like default interface member implementations. And we've also started exploring WebAssembly, so you'll be able to run C# in the browser. So where do you get all this goodness? Well, our GitHub repository is up on GitHub, obviously. We've been doing a lot of work to make it easier to process pull requests and so on. We have build infrastructure that automatically builds them, runs tests and so on, so you can see whether your code actually works before we merge it. We've switched from IRC to Gitter. IRC it's a little less accessible than Gitter, where you just log in with your GitHub account. So if you want to come and chat to some of the runtime team, check out our Gitter channel. We've switched our mailing lists over to lists.net. That's always awkward to say. And we've been making an effort to have more discussions about what's going on in the runtime in those public lists. And Google Summer of Code. This is something that we've been doing since 2005. I was actually a Google Summer of Code student back in 2005. I have mentored almost every year since, and been the admin for our project in that. So this year we have a lot of great students. Check out our blog if you want to follow the work that they're doing. There's also a Google group where they post about the progress of what they're working on. So thank you. If you have any So yeah, if you have any questions about Mono or VS for Mac or Mono Develop or IoT or any of that stuff, come talk to me or tweet at me.